Get out A1 Math, and today we're looking at comparing properties of linear functions. So there's a lot of different ways to compare them. Right now we're going to compare between an algebraic expression and a table. So let's take a look. So two things you want to do in this problem is find the initial value of f of x and g of x and find the range given the domain, which is 5 to 8. All right, so I'm going to start with f of x. So what is the initial value when I plug in my first x? When I plug in 5, I get 20. So my initial value is 20. All right. The next thing I want to do is I also want to find my range. Well, my range, well, it's going to start with the initial value, which is 20, because it's my y values, and see where it ends up. Well, when I get to 8, what do I have? Well, at 8, I'm going to end up with 32. So my range is going to go from 20 to 32. So that's taking a look at the initial value and the range out the table in f of x. All right, now we're going to take a look at it from the algebraic expression for g of x. Well, in order to do that, I'm going to plug in my uh, initial domain, my first x, which is 5, to find my initial value. And then I'm going to plug in 8 so I can figure out the range from the initial to the ending. So let's take a look here. We'll take the g of x is equal to 3x plus 7 and plug in g of x, which is 5, is equal to 3 times 5 plus 7, and solve that. And when we do, we get 15 plus 7, which is equal to 22. So it starts off at 22, and the first point in my range is also 22. And we want to see where it goes to. Well, to figure that out, we have to plug in 8. So I'm going to set it up again and plug in 8. 3 times 8 is 24. And then 24 plus 7 is 31. So the range from 5 all the way to 8 for my domain is going to be 22 to 31. And you could write that like this, but you can also write it as an inequality. So that's finding the initial value for each function, one for a table, one for an algebraic expression, and then writing the range of that. Go ahead and take a look at this next example. You could pause the video here and see if you can solve that. Okay, so taking a look at B, it has here a similar question. It gives us a table and for f of x and gives us a algebraic expression for g of x. Also has this little part here. It says the initial value is the output that is paired with the least input. The least input, that's our first x value. So that's going to be 6. So on both of these, it's 6. So that's going to be the answer here. So then we're going to plug in that 6 and see what we get. Well, for f of x, when we put in 6, we get 36. So the initial value is 36. The range is going to be from 36 to 60. Let me put my range in front of that. All right, now I'm going to go ahead and find what my initial value is when I plug in 6 for g of x. So I'm about to plug in 6 there. So I got g of 6 is equal to 5 times 6 plus 11. That's going to give me 30 plus 11. It's going to be equal to 41. So my initial value is 41. All right, now put one there. All right, now I'm gonna plug in as big as it's gonna go. So my range is gonna start off with 41. And where is it going to go to? Well, I figured that out by putting in my last value, which is 10. So it's going to be g of 10 is equal to 5 times 10 plus 11. It's going to be 50 plus 11 is 61. So you should get the range from 36 to 60 for f of x and the range for g of x 41 to 61. And you can compare the two. Okay, now we're still comparing the properties of linear functions, but this time we're comparing them between a graph and a table. A graph and a table. Okay, so when comparing these two, the table and the graph, you want to break them down individually and look at each one. So the f of x is the table and the g of x is the graph. I'm going to start off with explaining the g of x, the graph. So first you need to find your domain. Your domain is all your x values. So you want to find out from the graph how far to the left does it go. It goes all the way to -2. And then you say how far to the right does it go? It goes all the way to +2. So from -2 to +2 is where it goes. So that's going to be your g of x, your domain, from -2 to +2. Then you're going to find your range. How low does it go? Well, on the y-axis, it goes from 0 all the way up to 4. So it's going to be from 0 to 4. So on your first x value, what is your y? My first x value is -2, and my y is 0. So that's my initial value. My y-intercept, that's when it crosses the y-axis, when x is 0. So it does that at 2. And then the last thing I need to do is find my slope. My slope is going to be my rise over run. So when my rise over run, I go up 1 and over 1. So that's going to be 1 over 1, which is equal to 1. So my slope is 1. All right, so that's g of x. Now we're going to do f of x. And some of it's easier, some of it's a little bit harder, but none of it's too difficult. So all you're going to do here is go back and do all your domain. Your domain is everything from -1 to 4. -1 to 4. And your range is everything -1 to 4. So that's going to be here. So from the beginning to the end, -1 to 4. Your range is everything for your f of x, your y. So from 5 to 0, 5 to 0. All right, so your initial value, what's your value at the very beginning? Well, when I plug in the -1, I get 5 right here. And my y-intercept, what is this when x is 0? Well, x is 0 right here. And when x is 0, I get 4. So my y-intercept is 4. Now, the last thing you need to do is find the slope. Well, from a table, you can find the slope by looking at 2 points. So here's my 2 points. I just picked the first two, -1 and 5 and 0 and 4. X and a y, x and a y. And then plug it to the y2 minus y1 over x2 minus x1. And I got it over here on the right. And as you can see, the slope ends up to be -1. So that's how you end up with -1. So that's comparing information, domain and range from a table and a graph. Take a look at this example and see if you can solve this one. You can go ahead and pause the video here. Okay, you should get this. Um, your domain for your f of x should be all your x values, -4 to 1. Your range should be all your y values, f of x, so 4 to -6. Your initial value when you first put in your first x here is 4. Your y-intercept when x is 0, y is -4. And your slope, if you take these first 2 points here and plug it into the slope formula, you get -2. So that's f of x. G of x, how far to the left does it go? It goes all the way to -1. How far to the right does it go? It goes all the way to +2. How far up does it go, or down it goes? It goes all the way down to -4. And how far up does it go? Up to +5. So it's from +5 to -1. If you put -1 to 5, that kind of makes a little bit more sense either way. But then we take a look at the initial value at your earliest x, which is -1. That value is going to be was it at 5? So at -1, the highest it is, or whatever the value is 5. Then your y-intercept is where it crosses the y-axis, which is going to be at 3. And your slope go down to an over 1, -2/1, which means -2. Your slope is -2. Okay. Go ahead and take a look at this last example and see if you can solve this one. Okay, so if we take a look at this one, what you should have, we're going to start off with our f of x, which is going to be the table here. So the domain, easy enough, from -1 to 4 here. The range, -3 to 2. The initial value at the very beginning, -1 for x, you get -3 for y. Then the y-intercept, when x is 0, y is -2. And then next, we're going to find the slope. Over here in blue, I've got these 2 points here broken down. -2 minus -3 is equal to +1, and 0 minus -1 is +1. So your slope is going to be 1. So that's f of x. H of x, that's a linear equation. So it's similar to what we did at the beginning of the video. They give you the domain, which is -2 to 2. So from -2 to 2 is the domain. The range is when you put in your first domain and your last domain. So that's how you get your range. So I plug that in. So -2 plugged in for h of x is going to be equal to -2 plus 1, which gets you a -1. So the initial value in the very beginning of the range is -1. Then at the end, I plug in a +2, 2 here. So I've got 2 plus 1, and that's going to get me 3. So my range is going from -1 to +3. All right. Next, what we want to do is find the y-intercept and the slope. Well, that's real easy. If you remember your formula, y is equal to mx plus b. Whatever the m is your slope, and the b is your y-intercept. So in this equation here, h of x is like our y. It's equal to our slope times x plus our y-intercept. So the 1 is going to be our slope, and the y-intercept is 1 as well. Okay, so that's comparing properties of linear functions. We did it from a table to an equation. We did it from a table to a graph. Uh, in our next video, we're going to do it from an expression, from words, and a table or a graph and so forth. But for now, thank you for checking out A1 Math. Have a nice day.